Now we're going to get into our electric tool applications. For vehicle machinery, the predominant tool of choice that we're going to be talking about is the reciprocating saw. But just like we did with the pneumatics and the hydraulics and the other segments, we're going to start with that power source. So we're working off the apparatus itself. We're going to deploy our reeled lines, tie into the generator that's on the vehicle, and then work off those boxes. It's important that we know our boxes. We know the type of junctions that are on there, the outlets, and that we have an appropriate configuration of pigtails that are going to get us from supply point to operating tool. Some guys like to take these pigtails and configure them directly to the tool, have them pre-configured so the tool's ready to roll. Any other things that you guys utilize on your rescue, JD, to help make sure your pigtails are ready to roll?
I think one thing is this is bulky. So once we get this up to the area where we're going to work, we'll usually put another cord on there, a smaller cord that obviously is gauged for that saw. So we're not just having that short cord that comes attached to the saw and having to drag this thing around with us. We want something longer that's a little more maneuverable. It's not going to get caught on things. That way we can take that saw wherever we need to go. I mean, basically, that'd be the only thing I would add to that. But the pigtails are critical. If you don't have your pigtails set up so you can quickly grab the right one and hook it up and get that saw under operation quickly, you're kind of defeating the purpose here. We need to make sure that everything's ready to go as quickly as we can. So just have everything ready to go, know which one does what, and we get the operation underway.
Now when we're working off of a fixed supply point like the generator on the apparatus and these junction boxes, we typically don't have to worry about overloading that power supply. But if we go portable and we're working off of portable generators like this one here, JD, what other kind of things do we need to be concerned about when running our recip saws?
Well, before the emergency happens, make sure you go out, you train with whatever power source you have, your portable power source, and do it under load. Make sure it's not going to keep tripping the breaker on it. Make sure it has that output capacity to run the tool that you're trying to run. You don't want to learn that on the scene while someone's pinned. You want to know that beforehand. So if you're considering what to buy, then talk to the manufacturers. Make sure that you tell them, explain to them what tools you want to be using for that generator, and purchase the right one. Don't buy one that's not going to fit your needs. Another thing, most of them come with some sort of light, and it's a bright light. It can either be quartz, and now they're making LED ones, which has a whole lot less draw. But that quartz light is going to draw a lot of electricity. So keep that in the back of your mind. If you're running a saw or something off of this, you may not have the ability to have that light. You're going to have another light source and leave that light off. So you're not drawing power away from your saw. So we're not having to stop and reset. Stop and reset. We want to keep going until we accomplish the task that we're trying to get done.
When we start talking about reciprocating saws, there are a lot of variables on reciprocating saws. They all follow the same operating principles. They're all basically designed the same, but there's definitely some sizing variables that impact the capabilities of the saw itself. There's also accessory options. So these heavy and healthy saws are kind of the heavier end of the spectrum when it comes to reciprocating saws. One of the primary accessories that they have is a rotating D handle that could come up here and be configured on the front end of the saw. I think it's an important facet to have the ability to have with certain type of cuts. If you're extending out, trying to get to a remote area and make an effective cut, it's imperative that we maintain good control of the tip of this saw. When we're cutting, this shoe, which is adjustable, needs to have firm contact with the cutting surface. The way a reciprocating saw is designed with that stitching revolution, as we retrieve this shoe from the cutting surface, that's when we get into that likelihood of that saw withdrawing, bending, crimping over, and stabbing at the product rather than cutting through the product. You can see on the top of this saw in particular, we also have the option to adjust that action of the saw as to whether it's an orbital action or a straight action. That can impact your cut patterns. Another feature that I think is really important on recip saws is a speed adjustment or a revolution adjustment. When we buy blades and we put blades in these, if we ram these saws all the way up to full tilt speed, although they'll cut initially very, very quickly, That high level of revolution can heat up our blades tremendously, very, very quickly, and that over redundant friction is going to cause degradation of the blade. We're going to wear those teeth really quickly. Whereas a mid-range speed level typically will give us a lot longer duration of cut and just as effective of a cut. So one of the things we always encourage people to do with their recip saws when figuring out where that appropriate speed level is to do some side-by-side cut time trials where they're running their saw at a mid-range speed and a full-range speed and see, based on the duration of that blade, which one cuts the more more effectively or more quickly. So just keep an eye on that and really know the operating components of your saws themselves. JD, what other tidbits or guidance points do you have about the recip saw, and what are the applications for it? Where are we seeing this applied in an extrication type of application?
In an extrication, you may see it used, say the cutter's cutting the A and B post because they're the narrower posts, and if I have a wide C post, maybe someone will grab the Sawzall and we'll cut the C post with it. Always remember to expose the trim on inside, make sure there's no cylinders or anything in there before we do that, so we don't cut something that we don't want to cut. But if this goes to the widest post, usually you can accomplish, everyone will be done about the same time, if you have the manpower to do that. Windshields, it's a quick cut on a windshield. Once we get the roof, say we're going to remove the roof, we can shoot this right across the base of the windshield and get that accomplished pretty quickly. It does make a lot of dust, glass dust, so obviously take the protections that you need to prevent that becoming a hazard to you or the patient who's trapped. But on an extrication, that's primarily it. But like I said about the air chisels earlier, there may be a point where this is going to be my primary tool again. I can't get into, I can't spread, I can't get my cutters in, but I can get the tip of that Sawzall blade in there and maybe cut a nader or a hinge or a brake pedal or something like that. Some application where I can't use our primary tool, this becomes a primary tool at that point. As far as the blades go, when Dalen was talking about being up against the shoe, that's important. But there is a time where we have to come off that boot. And that could be that situation, say we're making access into the vehicle. If I bury my blade in, and typically 10-inch blade is primarily what we carry. They make shorter blades, you can switch them out pretty quickly. But if I'm in the middle of that cut, and if I go too deep, I get in on something I don't want to be on. It could be a seat back with the bars that are inside the foam. It could be a patient. It could be anything like that to where I have to back out, use my hands, my body, to control that saw. Now, if it's going back and forth on you, it's not working. Go to plan B. You should have a plan B already. But there may be a time where you need that tip of that blade. Sawzall, reciprocating saw, air chisels, anything like that, if we come against something that's vibrating, I'm making my cut, I come against something that vibrates, you can push all day long and you're not going to cut, because if that vibrating metal's there, it's not going to allow the teeth of your blade to cut it. Same thing with the air chisel. If I get on something and that's vibrating, I'm not going anywhere. So fix it. Do whatever you have to do to fix it. Go someplace else, get off of that, do something to correct that problem, because if it's vibrating, you're not going to make it you're probably not going to make much progress at all. So change your tactic, figure something else out. Relocate your saw blade or your chisel tip, whatever it is you got to do. Don't stay there in that one spot and keep pushing and pushing and pushing. You're not making progress. Change your tactic and get it done.
When we're talking about the blades themselves, it's important to note what type of blade is going to be the most effective for vehicle and machinery applications. So we're typically talking about bimetal blades, not demo blades, not fine metal blades, but a nice versatile bimetal blade. What is a predominant length, JD, that you guys are most comfortable with?
I like 10 teeth per inch.
Okay.
That's kind of middle of the road. It'll cut metal really well. It's not so coarse that it's beating your saw to death going through. It's not beating you up going through, and it's also not so fine that it's taking so long to get through the metal, because it's clearing it out so slowly that we're not efficient in what we're doing. So I'd say a rule of thumb would be 10 teeth per inch.
It's a good rule of thumb. When we're inserting the blades, basically every recip saw is going to have a little bit different design feature, but it all functions the same way, where we're going to rotate or articulate the capture mechanism within that interior piston, drop that blade into place, and then lock. it's real important that we ensure that that blade is fully seated and give it a quick manual jerk to make sure that it's not going to blow out as soon as we start to operate the recip. You can also see that underneath here we've got a detent button that lets us control the depth of the cut or the adjustment on this boot so that we can manage that element within a small margin. And then if we get into that application like JD was talking about, where it's so important that we have some versatility about being able to think outside the box, utilize the tool in some other applications, if we've got to do a reach out and a tip cut with that blade, we want to use some type of body part as a guide to control the depth of that so that it's not beating us back and forth just like JD was talking about. So here's an example of a blade. You want to watch your wear patterns on the blade, and you can a lot of times tell when you look at the wear pattern as to whether or not you're effectively utilizing your saw. Right. Talk about that a little bit, JD, and how when we're in that same place over and over again, what we're actually doing.
Well, I think what you just showed with adjusting that shoe, if I wore my blade out right here, what you're going to do, because that's where it's cutting, and I can adjust that shoe out a little bit, that puts me in a different part of my blade. I have fresh blade from here out. So rather than taking the time to switch out the blade, if you can adjust it or maybe back out and use your hand to control the saw, this is ideal. I mean, because you're still going to be on the shoe. But if you don't have that type where you have an adjustment there, then back out and use a good part of the blade. Eventually you're going to have to switch it out. I understand that. But if I can go from this point right here cutting to this point out here where I have good blade, why not do that? It's going to be quicker than stopping and switching out a blade. It's ideal to have a couple saws, a couple reciprocating saws on the scene. One gets ready to be changed out, you set it down, you pick the other one up, and keep right on going. So, it depends on the resources you have available to you. Another thing about the blade is, I can put the blade in this way with the cutting tips, I guess conventionally, or I can rotate my blade and put it in unconventionally, I guess you would put it. The reason I would do this is, if I'm using this saw and I'm trying to get into a tight spot, so who knows where it is, but you're trying to get into a tight spot. I've got the handle and I may have a cord. If I'm using a battery recip saw, I'm going to have a battery pack possibly down here. So by rotating that blade and putting my teeth facing this area, that gives me a flat surface. So now I can get this saw into a tighter spot, using my blade almost in line with the back of my recip saw, and get into that tight spot and hopefully get that cut down. If I have it the other way, I'm going to have to do some pivoting, and I may not have that room to do that. So just keep in the back of your mind that you can rotate that blade around if you need to accomplish the cut.
There's a lot of advancements being made in battery-based technologies. You do have the option to go with reciprocating saws that have battery packs, and then you can get joint battery packs that not only give you a battery option, but also the option to work through that battery into a full electric application when your battery starts to run low. JD, what's your opinions and your perspectives on the battery-operated applications for recip saws?
I think they have a definite place. Obviously, the only limitation to them is the battery life. And that's improved dramatically over the years as far as the time frame you can cut without having to switch out batteries. So having the ability to have both, I think, is great, because there's times where we could pull that battery saw off, start doing what we need to do. In the meantime, the driver or somebody else on the truck is stretching out our power cords, getting our electric tools hooked up. So if I do get to the point where I'm starting to go through batteries, all I do is look down, I pick up the electric saw, and I keep right on going. So it definitely has a place. We're going to be in, other than vehicle extrication, we're going to be using these tools in other places. So you may not be able to get that electric line down into the area where you work, or it's not a good idea to do it for some reason. Then my battery-powered recip saw is going to be my first choice on that. But just if you can have the versatility of having both, it'd be ideal. I think that way, there's no downtime, basically. You're starting your cut, battery's dead, I keep right on going with my electric saw. Very, very little time is wasted, and that's what we want. We want to be as fast and as safe as we can when we're doing this stuff.
Now, one of the moderately controversial discussion points that can be made about reciprocating saw blades, especially in our applications, is something that's tough to cut. Like if we're trying to tackle a high-strength steel or reinforced steel component, we're really eating up blades. One of the things that can reduce some of that heat friction and increase the effectiveness of that reciprocating saw is lubrication of the blade. But there's some downsides to it too. JD, what's your thought processes on applying lubricants to the blades when we're cutting with recip saws?
I think there's times where it definitely is a benefit. I mean, it's an obvious difference with or without it. I think we just have to be sensible in what we choose to use as a lubricant. I mean, soapy water, you know, a good bit of soap in it, you squirt it on there. If you have that person who can stand there and do that while you're cutting, manpower-wise, you may not have that. But when we start looking at other things, and you're looking at the container, and it's telling you that it's flammable and it's highly flammable, is that something that we want to be using on a heated up blade who occasionally starts throwing sparks? Occasionally, not very often, but it can. So in my opinion, would I rather have the soapy water going on there that is not flammable, it's not going to ignite, or do I want to use that spray can of some fluid that's highly flammable? So you make that call. It's going to be your department's policy, I guess, if you'd put it on something like that. But I would err on the side of having that non-flammable material.
All right, we're going to talk about some gas-powered applications for cutting and extrication, specifically the rotary saw. When we talk about the rotary saw, it's important that you select an appropriate size saw. There's really big saws, there's really little saws. You want a mid-range saw that's maneuverable and easy to operate. This is a much larger style rotary saw, and it takes a beefier guy to be able to manipulate this into different or various type of cutting positions. In a moment, at the conclusion of this, you're going to get into all the operating facets and the ins and outs and specifics of the saw with Captain Lash. But right now, JD and I just want to kind of discuss where we see this saw typically being applied in an extrication application. So why is it limited? It's a limited application in our perspective because anytime you're cutting ferrous metal with a high revolution blade, whether you're using an abrasive, a fiber abrasive, or a multiversal blade just like this one, you are producing a tremendous amount of heat and sparks. So when we start talking about applications with this that have any interior implications, we've got upholstery, we've got carpet, we've got foam, we've got all these highly flammable elements on the interior of the vehicle that can be very problematic if we're generating heat and sparks. On the outside of the vehicle, we've always got a flammable concern because we've got fuel tanks and potentially leaking flammable fluids. So in that initial assessment, just so we talk about in our tactical assessments, we're always ensuring that that line's on the ground, that we've managed any potential fuel spills, but we're really increasing some potential hazards with this saw. JD, for your guys, where are you guys typically utilizing this in extrication applications?
Rarely are we going to use it with people trapped inside of a vehicle, say to cut an A post or a B post or a C post or something like that, because of that. There's so many sparks, the fluids, the risk is way there. Is it fast? Absolutely, it's fast. But sometimes that speed is overshadowed by the safety of the operation. So I'm not saying you'll never do it. I'm just saying it shouldn't be one of those things that should be right on top as number one for normal cutting. A school bus, for example, we can cut the side out of a school bus quickly. I mean fast with one of these. But it blows so many sparks inside of that bus and onto the ground that to me it's not worth the risk. I'm not saying never, I would never say never, but it's not going to be something I'm going to feel comfortable doing, and there's going to have to be some real specific reason that I would do that. You know, we can have hose lines in place like we should, but when you have that fire, that ignition start because you're doing something like this, it's throwing sparks all over the place. Maybe that wasn't a good plan for us. There's different blades. There's all kinds of different options open to you, but the sparks, unfortunately, the sparks are the main negative in extrication like this. If we're just trying to cut a hood, you know, we have a car fire or something like that where we can get ourselves in position and make 2 quick cuts and get that hood up quickly, sure. But I'm talking about people truly trapped, they have no way of getting out, and we're throwing sparks all over them inside of this vehicle. I don't know. You better think that one through pretty good.
Yeah, I fully agree. For us, it's the same application. This is predominantly an exterior type of extrication tool. We're utilizing this for hood access. We're utilizing this as just curve cuts or drop cuts on frame rails, heavy structural elements that are on the outside of the vehicle, removed from that insulation, the patience, all those components. So think thoroughly through the applications and the implications or the consequences of utilizing this saw, we should say, and then make sure that you got an appropriate size saw. For more information on the saw front to back and the operating elements, make sure you check out Captain Lash's segment in our ladder channel about rotary saws.